I'm Corrado Leita. I'm a member of the European branch of the Semantic Research Labs group. We are mainly a group that is involved in collaborative research, either with academic partners in the context of different types of projects, or with other industrial partners. So what I'm going to present here is actually joint work that we have been doing among a set of colleagues and Olivier Tonard that has led, on the one hand, to a portion of the Semantic Interim Report on Rogue Security Software last year, and has recently led to a publication to an academic conference, RAID 2010 in Canada. So you can see in this slide a wombat on one side, so you may wonder what's the connection actually between this cute Australian animal and RogueEV software. So Wombat is actually a European project funded by the FP7 program. It's actually an acronym for Worldwide Observatory of Malicious Behaviors and Attack Threats. Wombat is an attempt to put together different institutions, both academic and industrial, that have a skill in either collecting data about malicious threats or about analyzing data, so malware analysis and similar things. What's the final purpose of Wombat? What we are trying to do is we are trying actually to collect data about things, so what is actually going on. So we all know there are vulnerabilities, but we don't actually know very much about which are the vulnerabilities are used in practice and which vulnerabilities are not very used. We don't know anything about the real sophistication that is behind the nowadays internet threats. We are trying to find answers. So we collect data, we take advantage of the data that we collect to build on top other metadata like malware clustering, malware analysis of different types. And we often try to build a big picture of how these different threats look like, so that we can improve our intrusion detection systems, our security software, and we can eventually lead to better collection methodologies to even learn more. Well, in practice, what does it mean? In practice means that we are trying to play the game of connecting the dots. That is, we collect data, basically we try to find the points in the threat landscape, we generate metadata, we generate contextual information, the numbers associated to the dots, and ultimately we try to do some sort of partial attack attribution, try to find out actually how things stick together and what's the big picture that we can get out of it. So this kind of methodology is exactly what we have applied on Rogue Security Software. So for those of you that maybe are not completely acquainted with this concept, a Rogue Security Software is a misleading application. It's an application that pretends to be a good application, something that actually will clean your computer from threats, but is not actually the case. So either it doesn't actually clean your computer, just asks you for money in order to pretending to be cleaning your computer, or it may even help other malware samples to actually get installed on your computer. It gives you a false sense of security in a way. Why do people do that? The main motivation behind this kind of threat is money. That is, users are so much aware of security, they're willing actually to pay to clean their computer as soon as you tell them, hey, there is something on it. And there are rumors that say that actually they are actually very good in propagating, so the propagation strategy is particularly good. What are the challenges that these attackers actually try to deal with? That is, they try to actually appear legitimate. They try to look as much as possible as good, nice guys that actually want to help you in cleaning your computer, initially for free, then they tell you, well, no, we would like you to pay something in order to remove the specific threat because it's particularly bad, so we want you to buy the full version of our product. And guess what? In the end, you pay and they tell you, hey, we have removed it, but maybe the threat didn't exist in the first place. So just to give you an idea, this is actually one of my favorites. This is actually a web page that was coded in HTML and JavaScript. When you browse this web page, you can see something that looks like your typical Explorer window. You have a cute bar that tells you, hey, I'm scanning your computer to see if you have threats, and then you have this pop-up that tells you, hey, I found something. Whatever you click, it doesn't matter. You'll be redirected to a page that will offer you, for free, an antivirus that will tell you, hey, I'm cleaning your computer from all your problems. When you tell him, hey, okay, clean it now, they'll tell you, hey, please pay me $50, something like that. And people will be lured by the scare of saying, hey, I'm infected, will be lured into paying. So There have been actually a lot of fuzz in the last year about the rogue security software, so a lot of people have talked about it. Mainly all the analysis were actually specifically targeting certain classes of threats, like people have looked at a campaign that's called Antivirus 2008, TrafficConverter.base. What we tried to do was a little bit different. We said, okay, well, let's try to look at the big picture. How actually these people in general are working, how they actually deploy these campaigns. Is there anything different from the other threat landscapes? So, do they use browser exploits to propagate, or do they actually do something different? So, how did we actually target this question? How did we actually try to find an answer? Well, we had a set of challenges. On the one hand, we wanted to have a relatively good data set. We wanted to have a sufficient amount of samples of these rogue EV domains to be able to say, hey, what we are seeing is a general property of the rogue EV threat scenario. We wanted to collect information about these domains. So once we had this list of domains, we actually wanted to get information about them. So what they are actually, what they actually do look like. And finally, we wanted to find a generic way to mine this information and actually infer lessons, infer something about all this. So how do we actually proceed? We took advantage of one actually of the tools that have been developed in the context of the Wombat project that is called HARMOR, that is a historical archive of malicious URLs. Yes, we like acronyms. So basically, the way in which we proceeded was over 3 different steps. First of all, collecting data about various malware domain lists, about rogue EV's domains. Then we tried to enrich this data by adding basically metadata such as DNS information, whois information, and so forth. And we ended up in generating feature sets, so characteristics for each of the domains that we actually have been looking at. So, first step, generating the list of rogue EV domains. Well, we didn't actually start crawling on ourselves. What we did is we actually reused the work of others. So on one hand, we have Symantec that actually has an initiative that is called Norton SafeWeb that gives you, information about which domains are actually infected by a certain threat. Then we took advantage of other, open sources of malware domains, mainly, malware domain lists, malware URL, hostfiles.com. All these lists actually give you a classification. So they tell you, hey, we believe that this domain is associated to this threat. We simply selected all the domains that were associated to the threat of rogue EV. We did a step further. That is, okay, now we had information about all these domains, but we wanted also to have information about, other related domains that could have been of interest. What we did is we actually took advantage of passive DNS sources. What is passive DNS? Basically, they are databases. The one that we use is Robdeck.com. It's a free one. You can actually browse and look at it. Databases that maintain associations between IP addresses and the domains that are actually resolving to these IP addresses. It's much more than just DNS reverse resolution because you have the full list of the domains that actually have ever resolved to a certain IP address. So what we did is we actually collected all the domains that, thanks to this list, we knew that were actually hosted on the same servers as these rogue domains. So once we have this huge list of domains, we need to actually get information about them. We took advantage of this tool that we developed in the context of the Wombat project, whose data is actually freely available. So I will not spend time here to describe how to get access to this data, but if you're interested, you can just contact me offline and I can tell you more about it. So we basically collected information about the security state of the domain. So is it known to contain different threats, other threats than just the rogue EV domains? Is it blacklisted by Google? We got information about the registration state of the domain, so whois information, DNS relations, so which are actually the web servers that are hosting these domains. And ultimately we got information about these web servers. So basically we got simple geolocation information, autonomous system information, so which is the autonomous systems in which the server is actually hosted into. And we get information about server uptime, and especially the version string. That is, we started actually sending on a regular basis head messages to all these servers to look at the HTTP headers of the answer and actually get information about which kind of version the server was actually running. So we used all this information that we have collected and we have fed it into a tool developed in the context of the Wombat project. It's called Triage. Basically, it's a multi-criteria clustering method. So it's something that takes information about events on different levels, on different dimensions. That is actually what you can see. Can you use a pointer? So it takes information about the threads on different dimensions and different planes, aggregates the events according to the specific plane. So for instance, all the servers are actually hosted on the same server, and then does some sort of magic stuff in the middle, for which it ends up with a combined graph. So it finds events that are actually correlated over multiple dimensions. So for instance, domains that have actually been hosted on the same server, registered by the same person, or hosted on different servers, but actually using the same server versions, the same configuration. This allowed us to mine into this data that we have collected and find something that we believe are actually campaigns, so cases in which people have done some sort of coordinated deployment of a lot of domains. So far so good. There are actually a number of problems in our methodologies that we are aware, that we are not perfect. First of all, we cannot actually exclude that our data set is clean. This because we just relied on third-party sources. So we know for sure that some of the domains that we have actually tracked, although they were classified as being RogueEV domains, they were not actually the case. So they were not really RogueEV domains. On the other hand, we know for sure that these domains were tagged because of heuristics. For instance, they found the word antivirus in the domain name. But we believe that these heuristics are English language only. So we are sure that these heuristics would never catch, for instance, a RogueEV domain that is working in China. So we know that we are limited from these points of view. But still, we believe that thanks to these data mining techniques that we have used, in the case in which our data set is dirty, we will be able to clean the dirt away. So, what did we see? We actually looked at a total of 6,500 distinct domain names that we have collected over the period of approximately 3 months. These domains actually resolved to a total of 4,000 different web servers. We had a certain number of web servers that were actually hosting also green content, so things that we knew that were actually non-malicious. We had a certain number of servers that hosted RogueEV domains and also other threads that were not related to RogueEVs. And finally, we had a total of 2,600 something domains, servers that were actually hosting only RogueEV domains. So servers that had been deployed only for this specific thread, so for this specific task. So for this very last type of server, we tried to look at very high-level information. So for instance, the first question was, where are they located? So where are they actually physically hosted? Well, interestingly, actually, most of the servers that we have looked at were either in Germany, or in US, or in other European units. We almost saw now nothing in Asia. But again, if you go back to what we have seen before, we know that our heuristics for finding RogueEV domains are not perfect. So we cannot really say for sure that this means that this threat doesn't exist in China, or that simply we were not able to see stuff like this in China. What we saw for sure instead is that there was some sort of clustering with respect to autonomous systems. Also in other talks during the day, we have seen that there are some autonomous systems that are sort of known to be sort of tolerant with respect to bad things. So even if bad things are reported, they don't act immediately, or they don't actually do any strict control on that. So we did see that actually 40% of our servers were located only in 10 autonomous systems, so a relatively small number of autonomous systems. And finally, most interestingly, actually, when we looked at the version of the servers that actually these things were running, we saw that in a lot of cases, actually, the server version was the same. Some cases were, okay, not really interesting, like, okay, the standard Apache server version. But we had cases like this one, in which we had a very, very specific configuration for the web server that is not the standard configuration of any Linux distribution, that led us to believe that there was some sort of pattern. That is, that people, when they were actually deploying these servers, were using templates, were using some sort of pre-configured machines. They were just deploying them over VMs or over ISPs or over the cloud, and they were just reusing these kind of things. So to go more in depth, we need to go a little bit more into the details of these domains. So if you look at the big picture, it's sort of a mess. We actually, in this picture, you can see for the servers that were actually hosting the highest number of the domains, we have tried to picture in different colors, RogueAV domains in red, here, good domains, so domains that were actually not containing any threat as far as we knew, that were in green. And then there are some parts here that are actually in orange, that were actually domains that were containing threats that were not associated to RogueAVs. So what can we see from here? We can see that there seems to be some sort of, interest from the bad people to register a lot of domains over the same server. So they seem to be trying actually to evade name-based blacklisting. At the same time, you also see that IP-based blacklisting will not actually work with these things, because you have a lot of cases here in this big interconnected. I'm sorry, I forgot to say that these domains are actually grouped according to the server that is hosting them. So at the center of these great things, there is actually a web server. So you can see here a case in which all the domains, all the RogueAV domains have been deployed on a single server. And here you can see some cases in which these RogueAV domains are actually mixed with probably the domains hosted by some sort of service provider. So IP-based blacklisting wouldn't work, because if you try to do IP-based blacklisting for these domains here, you will actually block a lot of very good domains that probably have nothing to do with RogueAV domains. Here, same things, but actually more in depth. So we looked at the smaller cases, just filtering out all the green ones. So you can see there is, in a lot of cases, these kind of circles here. All cases in which somebody has deployed a server and then has deployed over them a large number of RogueAV domains. So this gives you some sort of feeling from a high-level point of view, but doesn't give you any detail on how actually things are in practice. This is where actually the third step of the analysis comes in, that is trying to cluster the domains, trying to mine the information that we have inside these domains to infer some generic lectures. So what you can see here is an analysis of the compactness, so the level of correlation between the different clusters for the 39 biggest and most interesting clusters that we have actually found. So out of these 6,000 domains, we've been able to group 39 domains that were hosting, 39 clusters that were hosting a total of 4,000 domains. So the big bunch of the domains was actually clustered into 39 big groups. You can see the usefulness of this. It's not really type attribution, not yet, because we're just clustering things. But still, if you have to deal and analyze 39 things instead of having to analyze 4,000 of them, things are actually a little bit easier. So let's look at some of these cases. So this is actually one of these clusters, a very small one. You can see with the blue circles, the domain names, so the domain that we actually have been tracking. They have this weird coloring in the moment in which they are also named servers. And in red, you actually have the registrants, so the people that register these domains. So what you can see in this case is that people have actually generated, probably with a simple algorithm, a lot of reputations of the words PC, anti, and spyware. And they actually have deployed these domains. You may not see it yet here very well, but actually they have deployed these domains on consecutive IP addresses. So they have used a range of something like 10 or 15 web servers associated to 15 different IP addresses, and they have used each of these servers as both a name server and a web server for each of them. The funny thing about this is that we found a second campaign that was completely different. So it was hosted in a different location of the IP space, was actually registered by different people, and was actually registered in a different time of the year. But this campaign had exactly the same characteristics. So again, if you look at the domains, well, you cannot see them, but I tell you, trust me. All the domains actually have names that are, again, permutations of the word PC security in 2010. And again, they are actually deployed on servers that are on consecutive IP addresses. So what this tells us is that we have two different campaigns, but with a similar modus operandi. So probably there is somebody that has generated maybe a bash script, or has some sort of guidelines on how to easily deploy this kind of RogueAV campaigns. Or maybe it's the same group that is actually doing it in two different points of time using a different ISP. So to give you an idea instead of the level of coordination of the bigger ones, I just put here one example. So here these blue masses actually are all domains. We call it the Chinese Great Wall, because all these domains actually, if you zoom, they are all .cn domains. And there are always random permutations of 6 characters. The interesting thing here is that on the low part here, you have the registration date. So what you can say is that somebody at a certain point in time, so it was something like in, I don't remember, it should be March, I cannot see, but at a certain point in time, they actually deployed, they registered a big bunch of domains, and they have actually deployed them on a server that was hosting this network, and then they started using these domains for a while. And then actually here, it's 6 months later. So 6 months later, they decided, hey, maybe all our domains have been blacklisted by Google, so these domains are not useful anymore. Let's register more. And so they register something like 600 domains in a second batch, and they continue like this. So this shows that behind this kind of threats, there is quite a big investment in terms of the cost of actually going to deploy the servers, registering the domains. Registering each of these domains has a cost. And actually then in promoting these domains to make sure that people visit them and end up in actually downloading software. So the last part that we actually tried to wonder is, why do people do this? We don't see this kind of campaigns in other types of threats. We don't see as much effort as this one, even in phishing campaigns. So we tried actually to investigate a little bit these rumors. Yeah, almost gone. Investigate a little bit these rumors about the RogueEV economics. So is it true that it's really such a good business? So we have tried to do some sort of informal survey. So we just went around and looked at the average monthly cost of renting a server, the registration cost of registering a domain. And so we can see that the deployment of a single domain or of a small set of domains normally has a range in prices between $800 and $2,000 per year. The point was, we didn't know actually how much were the revenues, so we did not know how many clients these people were actually getting. And in this, we have been lucky, because in looking at the servers, we have discovered that a small number of them, actually only 6 of these servers that we're actually looking at, were misconfigured. That is, people had left the mod status in Apache running with all the verbose information. So for those of you that are not familiar with Apache, mod status is a module that allows you to browse a specific page and get a full state of the web server. This comprises information about the load and similar things, but it also comprises information about the last 500 HTTP requests that the web server has served, with information about the IP address of the client that connected, and with information about the type of request size. Was it a GET, and what was the URL that was actually fetched by the client? So we filtered this data to remove all the scanning intents and trivial things that we were not actually interested in. And then we started classifying these URLs. So we started to classify, hey, this URL is actually pointing to a fake scan page, so a page that pretends that the user has threats, a little bit like the one that I showed you in the beginning. And we then classified other pages that were actually the pages in which people were downloading the malware samples. And this is actually what we found out. So here are actually the cumulative distributions of the IP addresses over the 2 months in which we have tracked these servers continuing to download this page on a regular basis. So what you can see here is the line of the scans. So the number of clients that actually have landed on the fake scan page, the page that was telling to the user, hey, you are compromised, you have a problem. And you can see here this other line in blue, that is the line in which the user is downloading the RogueEV sample. What happens is that in this specific case, the RogueEV actually is downloaded for free, and as I said in the beginning, what happens is that the RogueEV will come back and tell you, hey, if you want to be clean from these threats, you need to pay $50 or $60. Unluckily, we didn't end up in having information about the payments. That is, we could see when people were downloading the RogueEV, but we could not see when they were paying, for the simple fact that the page that these people were using for the payments was hosted somewhere else. It was hosted on a different server that actually we were not able to track because they didn't have the mod status page on. But still, we could see something very interesting. That is that the rate between the successful scans, so the rate between the visits to the scan pages and the case in which the client was actually then downloading the sample was really high. It was something like 7.7%, which is way better than what normally people are able to do with phishing. So we have been able to complete the table with partial data because we knew the average price for a RogueAV. We knew the client volume, so the total number of people that actually landed on the fake scan page. We didn't have information about the payment. We have seen that things were better, but for, as a lower estimate, we just used the very same monetization rate that has been observed for phishing pages, that is 0 to 26% in previous academic work. And what we found out is that even in this very bad case in which they were really unlucky in getting money out to the clients, they were able to monetize something like $400,000 per year, which is way better than what they were actually spending to deploy this campaign. So this just shows you that, yes, indeed, RogueAV software seems to be specifically lucky in, specifically good in luring users into downloading and eventually paying, at least for the partial information that we could get. So what did we learn out of this study? Well, first of all, we learned that the user has an important role. Here we're not talking about browser exploits. We did find a small number of cases in which people were actually also putting browser exploits on the very same RogueAV page. In most cases, the user was clicking on the link, was downloading the malware sample, and was eventually paying for that. What we saw also is that the relationship between, we saw a lot of domains, so we saw a lot of cases in which people were, deploying these RogueAV sites, but the number of domains instead, the number of servers on which they were actually handling the payment was much lower. So this seems to suggest that if you want to attack this kind of threat, you should not focus on the specific RogueAV pages because there are just too many. You should focus instead on the payment sites. If you find the payment sites, it's much easier to actually stop them. And finally, blacklisting is trained. We have seen it before. And in general, we have seen that DNS is a very good place to look at. So if you're able to do something at DNS level, so look at the DNS requests, these kind of things are really visible because there are a lot of weird things in the resolution of the domains, in the fan out between the number of servers and the number of domains. So DNS is a good way to go. So with this, I'm done. And if you have any questions, if I have time, I will be happy to answer. Yes? I cannot hear, sorry. In this specific case, actually, we were looking at a total of 6 servers. So we could manually verify, and we could really see that this URL was pointing to a file that we downloaded, and we tried, and we saw that it was actually a RogueAV. So we could do it manually, because it was a very specific case. On these servers, there was nothing else. It was RogueAV. They were specifically deployed for hosting RogueAV software. There are cases in which the RogueAV, so there are cases in which, the simple case is a case in which the RogueAV virus simply simply tells you to pay. There are cases that have been documented in the literature in which the RogueAV instead is a Trojan. But here again, we didn't want to look at the specific RogueAVs. We just wanted in the end to have some sort of information about how much money they were making. But the idea was really to look at the infrastructure, so look at how these people are actually deploying these servers. So we didn't look specifically all the domains.
Corrado, thank you very much for your time. Unfortunately, we have to press on for the rest of the